When calculating the differences of a set of data manually, then the value that the researcher can form is the t-value. From the t-value, the researcher will compare it to the critical values table, which will be able to determine if the difference between the two sets of data is significant or not. The researcher will use the dependent t-test when the data is normally distributed, as it's a parametric test for difference, but also when they use the same participants, as the test is dependent. So the same participants were used in the two groups for the data set. So same people, both pre and post intervention, were used. In this example, the researcher took scores pre and post intervention to calculate the difference to see if there was a significant difference of the intervention. Shown in figure 40, once I had got my initial calculation, then I multiplied 6 by 52, which equaled 312. Then I multiplied minus 16 squared, which equaled 256. I then subtracted the 256, the previous number, from 312, which equaled 56. From that, I subtracted 1 from 6 to give me 5. I did 56 divided by 5, which gave me 11.2. Then I found the square root of 11.2, which equaled 3.3466400106. Then I found 16 divided by that number, which equaled negative 4.78 2 decimal places. Minus 16. Which gave me the t-value. I got these values from using the table of results I'd already collected and then putting them into the equation. So following on from this, comparing the t-value to the critical value table and using the standard level of significance, it equaled that there was not a significant difference, as the calculated value was below the critical value. The critical value was 2.571. However, the calculated value was negative 4.78. Therefore, it wasn't above the critical value. So there was no significant difference. Another parametric test used for difference can be the independent t-test. Once again, it's used when the data is normally distributed. However, the research design is independent, so different participants were used for the two different groups in the data set. So the t-test is used to find the difference of two sets of data from different participants. Using the equation of the independent t-test, then from my initial calculation, breaking down the equation into smaller parts, I was therefore able to calculate the t-value. So firstly, on the top half of the equation, I did 2.366 take away 1.66, which equaled 0.706. In the bottom half of the equation, the two standard deviations squared, then divided by 10, so the number of participants in each group, then summed together equaled 0.01381. And the square root of that value was 0.1175159564. So then going back to the top value of 0.706, that divided by 0.1175159564 equaled 6.01 to 2 decimal places, and that was the t-value. So calculating the values all in the table in figure 43 and then putting them into the equation allowed me to get the t-value. So comparing the t-value to the critical value table, there is a significant difference, as the calculated value was 6.01, and it is then greater than the critical value of 2.101. Therefore, there is a significant difference between Group 1 and Group 2's flying sprint times.